Hi people, welcome to the 13th part of the statistics series. In today's video, we are going to talk about p-values. Before watching this video, it's better to watch my previous video on hypothesis testing. If you have ever wondered how scientists determine whether a result is statistically significant, p-values are the key. What is p-value? P-value is a number that tells you the probability of observing a certain result if null hypothesis is true. The null hypothesis is the idea that there is no difference between groups or no effect of a treatment. So if your p-value is low, that means it's unlikely that your results occurred by chance and more likely that there is a real effect. How is p-value calculated? P-values are calculated using statistical tests such as t-test or ANOVA. These tests generate a test statistic, which is a number that summarizes the difference between groups or the effect of a treatment. The p-value tells you how extreme this test statistic is, or how likely it is to occur if null hypothesis is true. Hypothesis testing and p-values. Hypothesis testing is the process of using statistical tests to determine whether there is an evidence to reject the null hypothesis. The p-value is a key component of hypothesis testing because it provides a measure of strength of evidence against the null hypothesis. If the p-value is less than the predetermined threshold for statistical significance, then we reject the null hypothesis and conclude that there is a significant effect. Example, let's say you're studying the effect of two different diets on lifespan of mice. If the mice live equally long on either diet, then the test statistic from your t-test will closely match the test statistic from the null hypothesis, that there is no difference between groups. And the resulting p-value will be close to 1. It likely won't reach exactly 1 because in real life, the groups will probably not be perfectly equal. If, however, there is an average difference in longevity between two groups, then your test statistic will move further away from the values predicted by the null hypothesis, and p-value will get small. The p-value will never reach 0 because there is always a possibility, even if extremely unlikely, that the patterns in your data occurred by chance. What does p-value mean for research? P-values are used to determine statistical significance, which is a way of saying that a result is unlikely to be due to chance. The most common threshold for statistical significance is p less than 0.05, which means that there is less than 5% chances of observing the result if the null hypothesis is true. However, this threshold can vary depending on the field of study and the specific research question. The level of significance is usually represented as p-value between 0 and 1. The smaller the p-value, the more likely it is that you reject the null hypothesis. But if p-value is lower than your threshold of significance, though the null hypothesis can be rejected, it does not mean that there is 95% probability of the alternate hypothesis being true. A p-value less than or equal to 0.05 is considered statistically significant. It denotes strong evidence against the null hypothesis. Since there is below 5% probability of the null being correct, so we reject the null hypothesis and accept the alternate hypothesis. However, a statistically significant result does not prove a research hypothesis to be correct. Instead, it provides support or provides evidence for the hypothesis. Now, a p-value greater than 0.05 is not statistically significant. It denotes strong evidence for the null hypothesis being true. Thus, we retain the null hypothesis and reject the alternative hypothesis. We cannot accept the null hypothesis. We only reject or not reject it. Example, statistical significance. Going back to our example of two diets and mice. Let's say that your comparison of two mouse diets result in a p-value less than 0.01, below your alpha value of 0.05. Therefore, you determine that there is a statistically significant difference between two diets. This means that difference in lifespan between two groups unlikely to be due to chance and more likely to be due to different diets. So there you have it, a brief introduction to p-values and how they are used in research. Remember that p-values are just one tool in statistical toolbox and shouldn't be used in isolation to make decisions about research findings. As always, it's important to consider the context, the study design, and the limitation of data before drawing conclusions. So, thanks for watching. I hope my videos are helping you to understand statistics and their concepts. If the video is beneficial, please share, like, comment, and subscribe to my channel.